Okay. I think that you probably need me to go over these warm-ups because you probably forgot everything. So that's okay. That's why I'm here and have a job at this nice establishment to help you remember the things. Okay. Number 15, rewrite each series using sigma notation in terms of both T0 and T1. Okay, so make two sigmas. This one's going to be our T0. This one's going to be our T1. And the first thing I'm going to do is number the terms 1, 2, 3, 4, 5. Okay. Everybody clear so far? Okay, I'm going to use N. There it looks like they're using M down here and K. I'm going to use N. I'm probably going to use N every time that I do these, that it's not given to me. I'm going to say, I'm going to start at 1 and go to 5. I'm going to start at 1 and go to 5. That part of it doesn't change. Okay, now this one, can you guys tell me if it's arithmetic or geometric? Geometric. It's multiplying by 4. It's times 4, right? Okay, so it's problem number 81. It says if we do term 0, you put term 0 times the multiplier to the n. Okay, so I'm going to make my backwards arrow. And if it's multiplying by 4, then term 0 would be 4 also. Does that make sense, everybody? Okay, so you have term 0 times the multiplier to the n. Okay, and then if we do term 1, you put term 1 in the front instead, times the multiplier, and then you back up 1 spot to balance it out. So term 1 is 16, multiplier is still 4, and then n minus 1 to balance it out. Okay, any questions about that? So tonight's homework is the quiz review. The first couple of questions are asking you to do this. It's also going to ask you to do it for an arithmetic. Just in case you need to, you can look up how to do term 0 and term 1 for arithmetics in 10-24, just as a reminder, if you're working on the quiz review and you have an arithmetic, the equations for term 0 and term 1 are in 10-24. Okay, anyway. Number 17, evaluate each arithmetic series described. Evaluate means find the sum. So every time you see that word evaluate, that means find the sum. And the sum formula for an arithmetic is n over 2 first term plus last term. Okay. Sum equals, how many terms are there in problem number 17? 5. So the question you're asking yourself is how many numbers are there between 1 and 5? And the answer is 5. Okay, and then what's the first number? I don't know, but I can get it by plugging in 1. And what's the last number? I don't know, but I can get it by plugging in 5. And type in one fell swoop. Answer is 50. If you forgot the equation for geometric, which I'm quite certain that you did, you can find that in problem number 83 to 85 in this box right here that says sum equals blah, blah, blah. So that's the formula for geometric when you get to that on your quiz review. Okay, now if you guys could flip to the stamp sheet side real quick. Okay. Today, we're going to do infinite geometrics. And remember, before break, I was standing over there and I was all cute and I was like, remember this moment about how like it all adds up to really close to 10? And you're like, and I was like, you're gonna forget this. And then I'm gonna say, remember it. Me saying over here, how like this adds up really close to 10. Well, we're gonna look at why that adds up really close to 10 today. Do you all remember? Yeah. You know what? It's fine. It doesn't matter. It's just a really weirdly timed lesson before spring break and after spring break that where one ties into the previous one. It happens all the time. Then we play it or live. Anyway, on the block day, so it's weird because it feels like Monday, but it's Tuesday. Tomorrow's actually block day, 135. You do not have this class tomorrow. And we're going to do the past practice test on your computer. Doesn't matter what grade you're in, you're gonna do the past practice test. Everyone's gonna do it. It's not hard. You can talk about it with each other and work together and all that. I just want you to see the tools and look at it. And then when you're done with that, you can work on your quiz review again in class. That is 2 nights homework, so it's not due till Friday. However, your quiz is Friday. On Friday, we're gonna do mazes, which are in your packet, and the quiz. Does anybody know if Friday is a TPT day? It's not, okay. Okay. While we're here, I just want to talk about this real quick. Your quiz topics, just for your quiz review. It's Friday. There's no notes, however, the formula for the sum of an arithmetic, the formula for a sum of a geometric, and the quadratic formula are printed at the top of the page. So you do not need to memorize those formulas, they will be there for you. Oh, my Zoom has finished downloading from first period. Okay. Oh, don't care where I save you. Okay. There are 3 questions. First question is, given a sum in summation notation, find the terms and find the sum. And we just did that. That was number 17 in the warm-up. So you have the sigma thing, and you put n over 2, and then you plug in 1, and then you plug in the last one, first one plus last one. We did in the beginning of theory, write it in summation notation and find the sum. We just did the writing in summation notation bit. And then use one of the formulas to find the sum, depending on if it's arithmetic or geometric. And then find the number of terms in an arithmetic series. This is the one that we did, which was the last one, number 95, which was quad formula, and it has to come out to a whole number. Note, it says no notes allowed, but you are allowed a calculator. You have to have a calculator for this one. It would not make any sense for us to not give you a calculator. So calculators, yes, notes, no. However, those formulas are printed at the top. Sum of an arithmetic, sum of a geometric, and the quad formula are all printed. And those are all in the quiz review also, so of course. None of the things that we're doing today, however, are on there. This is just the stuff from before break. Okay, done with the packet. You can just slide that aside. This is the problem I was talking about that came out really, really close to 10. And I said, you guys are going to forget this. But remember me saying something about this problem coming out really close to 10? And then number 95 is the one with the quad formula, if you want to go back and look at that when you're doing your quiz review. Okay, you guys go ahead and set up 111, please. Yes, we're that deep in the chapter already that it's 111. I know. Crazy. Are you guys ready for 111? Why does she have a weird line there? Why is there a sigma already chilling there? It's so that I'll remember what to do. Okay, number 111. We actually need to go to the book. I know. Weird. The bouncing ball. Imagine lying on the ground and tossing a ball straight up 10 meters. By the way, that would be really hard. 10 meters is very high. Shh. This is a contrived math problem. If you can toss a ball up 10 meters, that is impressive. Anyway, when the ball gets back to you, how far has it traveled? This is kind of a dumb question, but I like to make a little picture of what it's doing. So take your little line that we made with graph paper, and we're just going to make a little picture. So you are lying on the ground, you tossed it up 10 meters. it came back to you 10 meters. So its total distance is 20 meters. I know that seems kind of silly, but it's going to help as we go through the problem. B. Instead of catching it, imagine that you let it bounce. The ball has a bounce ratio of 60%, meaning that each time it bounces, the ball will bounce to 60% of its previous height. Right now, you should be having some Math 1 flashbacks of dropping a golf ball and videotaping it and finding out how high it came back up after you let it bounce outside. Nope. Okay, that's maybe a Mrs. Talbot, Miss Rice thing. Nobody else? Nobody dropped the ball and videotaped it? No. Well, it was fun. When the ball comes back down to you the second time, how far has it vertically traveled in total? Okay, so if it has a bounce ratio of 60%, we're going to do 10 times 0.6. This means that the original bounce was 10, and it's only going to go 60% of its original height, which is 6 meters. So on the second bounce, it's going to go up 6 and down 6. So its total distance after 2 bounces would be 32 meters. Everybody good so far? Okay. C. Imagine that you let the ball bounce 15 times. Write a geometric series to represent the total vertical distance the ball travels until it comes back to you the 15th time. What is the total distance the ball will travel up and down? Okay, so in my spot right above this, I'm going to say, okay, the first, put a parenthesis, by the way, and I'll explain why in a second, but the first bounce was 10 high, and the second bounce was 6 high. And how could I find the next one if I had, say, this magical device? Yeah, okay, so 3, I actually know the answer, 6 times 0.6. And I'm going to say to 15 terms. That means that I would have to get 15 numbers. And this is not exactly right. This represents only the bounce up part. But if we're talking total distance, doesn't it make sense that I need to multiply the whole thing by 2? Okay, so now I'm going to do is I'm going to translate this down to sigma notation. So sigma notation, you can actually do operations on, but let's just start it how we started it in the warm-ups. So we are saying that we're going out from term 1 to term 15. We didn't calculate them all. We don't need to. That's okay. We're going from term 1 to term 15. So I'm going to say n equals 1 to 15. Then I'm going to say I'm too lazy to find term 0. So I'm going to write this in terms of term 1. When I write it in terms of term 1 goes first, then the multiplier, and then I have to take 1 away from n to balance out the fact that I started with term 1 instead of term 0. Okay, but for this to make sense, I have to multiply everything by 2. So I'm going to put a 2 in the front. Okay, now it says find the sum. So find the total distance it traveled in 15 bounces. This is geometric, so the formula is first term times multiplier to the n minus first term over multiplier minus 1. Okay, first term is 10. Multiplier is 0.6 to 15 terms. Minus the first term is 10 over multiplier minus 1. You guys remember what I said about parentheses? Anybody remember? Parentheses around the top, parentheses around the bottom. Okay, however, what do I need to do to this to get the total distance? Multiply by 2. Okay, so now I'm going to ask you a physics question. Okay, put your physics brain on. Yay! I'm not a physics person. I don't like to apply my math to anything. I just want to do math, get exercise five and walk away. But now, dang it, there's reasons for math and that's physics. Okay, so imagine, I know that 10 meters is very high, but imagine that I let it bounce 15 times. Would it be very far off the ground at that point, 15 bounces later? No. Okay, does it make sense to you that if I did not apply the laws of friction to whatever the ball is hitting, that it could theoretically bounce forever? Does it make sense to you that if theoretically I let it bounce forever, that each time it bounced, it would just be a little teeny tiny bounce? A little teeny tiny, teeny tiny, teeny tiny, teeny, teeny tiny. Okay, so if I'm only going to be adding little teeny, teeny, tiny, teeny, tiny amounts as it keeps bouncing past 15 bounces, what do you think the total distance would be if I let it bounce forever? 50. 50. Because remember how I said it was really, really close to 10? All of your big amounts are going to be in those first bounces. And then everything you add after that, forever to infinity, it's going to be tiny, 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 tiny. And if you let it go forever, it would go 50, which is really hard for us to wrap our brains around because we have a hard time imagining forever. Actually, we can't. Prove it. Human brains cannot imagine forever. Not possible. Maybe my buddy Chad can do it. Do you guys know who Chad is? Yeah, Chad, he can. Chad, his name is Chad. I asked Chad if he had celebrated Easter, he said no. But he said he respected cultural differences and also he liked it. Can you guys sit up 114, please? That's the only Easter thing I do. Guys, right. Okay, you sound ready. What we're going to do is we're going to take these two series and we're going to find the sum of 10 terms and find the sum of 30 terms and see if we can use the pattern to tell us what it would be for infinity terms. And like I said, our brains, we don't really wrap around infinity very well. So instead, we just think of really big numbers. Okay. So using this formula here, we're going to say sum equals first term times multiplier. What's the multiplier in this? You can tell two ways. It's right here, or you could tell from what it's doing. To the 10. So this is the number of terms we're going out. So first term times multiplier to the n minus first term over multiplier minus 1. Okay, type that in your calculator. Remember to put parentheses around the top and the bottom. Also, in your calculator, you should use 0.5 and not 1/2. It's much easier unless you want to use like double parens. I'm going to use 0.5 because I'm lazy. Take a look at my calculator if you need help. What you got? 399.6. Okay, so that's giving me some evidence. What's 399.6 kind of close to? 400. So I'm going to say my conjecture is going to be that if I ran this all the way out to infinity, it would add to 400. Let's check 30. So we're going to do the same thing. Except for we're going to add to 30 terms instead of 10 terms. And what I'm going to do, because I'm the laziest human being ever, is I'm going to scroll up 2 spots on my calculator and hit enter to copy and paste it. And I'm going to change this 10 to a 30. Ah. Hmm. Okay, so do you feel pretty confident in saying that if we took that series to infinity, it would add to 400? And it's true, it does. It's just that it's really hard to imagine infinity. Okay, now we're going to do this other guy. Same thing. We're going to do 10 and 30. So sum equals first term times r And I'm going to use 1.5 in the calculator for this because I'm lazy. To the 10 minus first term over r minus 1. Interesting results. Yeah, it's kind of inconclusive. Do you get the feeling that that's getting really close to any certain particular number? Not really. Let's see what happens with 30. Scrolly scroll, enter. 30. Huh. 6,136,001. I'm going to use a big girl word now. Do you feel like as I increase the number of terms, it is converging to a particular number? Okay, so let me use the word properly in this case. If I increase the number of terms, it is converging to 400. Do you feel like this is converging to any particular number? No, it's just going to infinity. Okay, so if I take this particular series and I take it out forever, it will add to infinity. What's the difference between these two series? Why is this one converging around a number and this one is just blowing up to infinity? They're both symmetric. Yes. In the first one, the multiplier is less than 1. The numbers are getting smaller. In the second one, the multiplier is greater than 1. The numbers are getting bigger. Okay, so this is, by the way, I have to write my infinities as 2 little circles, like a sideways 8. I can't do it. I cannot do it. I don't know what's wrong with me, but I can't make an actual infinity symbol. It's fine. If that's my life's limitation, I mean, other than like, say, the NFL, I mean, that's probably not in my future. Dream big, Mrs. Abbott, dream big. Playing on the Benicia High School football team is probably not in my future. That would be a lot closer than the NFL, but still probably not attainable. Okay. This is actually the last problem of the day already. I know, pure excitement. And it's actually the same 2 previous series that we were just working on, but now do you notice that there's a dot, dot, dot with no end? Okay, so that means that it's infinite. I didn't put the equation at the end this time, so there's no ending. It goes on forever as it is. So you have to keep your eye out for when it goes dot, dot, dot forever now. And you guys know, hopefully, that this one is going to be 400 and this one's going to be infinity. We already showed that this one was coming really close to 400 already, and this one was just blowing up really big. Okay, but there's a process that we do. What you do first is you find R. And you can find it just by common sense, by looking at it, or you can do my life hack, which was term 2 divided by term 1. Term 2 divided by term 1, which is 1/2. And you say to yourself, oh, is that less than 1? Or is it greater than 1? You can also think to yourself, are the numbers getting smaller as I go or bigger as I go? 1/2 is less than 1, so a sum exists. Okay, now the next question you might have is, I know it's 400. I can tell it's 400 from my previous trial and error. How do I get 400 without plugging in giant values of n? And the formula is sum equals first term over 1 minus r. And you only do this formula if the sum exists. Otherwise, it's infinity. So since a sum exists, because the numbers are getting smaller and because the multiplier is less than 1, we can find the sum. Sum equals first term over 1 minus r. Now note, this is not on your quiz this week. However, I am going to have it on the next quiz. There's actually 3 quizzes this chapter, and I'm going to ask you to show all of your steps. So this is not a calculator problem right now. You really want to put it in the calculator and get 400, but we need to do it properly. We need to do it with showing all of our work. So the first thing you do is get a common denominator on the bottom. 200 over 2 over 2 minus 1 over 2. Do you guys all see where the 2 over 2 came from? Just common denominator. So I took 1 and changed it to whatever the denominator was here. Okay, the top is still 200. What's 2 over 2 minus 1 over 2? 1 over 2, great. So subtract the top, bottom stays the same. Subtract the top, bottom stays the same. Now keep change flip. Keep change flip. And there's your 400 that you knew it was going to be because you did all this work up here to show that it was really close to 400. Okay, last one of the day. R equals 24 over 16, which is 3 over 2. Or 1.5. 1.5 is greater than 1, so no sum exists. This one is going to add to infinity. And this one is a no solution type problem. You just drop the pencil and end there. That's it. Don't do the sum formula. No sum exists. It's great. You guys remember, like back when you got a negative square root and you just put no solution and moved on with your life? Like, you get to do that again. So whenever the numbers are increasing or the multiplier is greater than 1, you don't have to do the problem. You just put no sum exists, infinity, Move on to play. Yay. It could be negative infinity 2%, but this one would be positive infinity because the numbers are all positive and getting bigger. But they're all negatives and getting, anyway, doesn't matter. Okay, last thing I want to say, so you guys know the homework is a quiz review, but it's not due tomorrow. You don't have me tomorrow. It's not due Thursday, due Friday. I would love to answer questions on Thursday. Also, full disclosure, I'm gonna stamp everything up to this tomorrow while you're doing your task practice thing in your group. So you should have everything done up through 116. I meant Thursday. I am so, this is gonna happen to me all week. I can't adjust. Now, but it is like finding a $5 bill in your pocket because you're like, oh, it's already Tuesday. And then I just keep reminding myself that it's already Tuesday. Guess what, everybody? It's already Tuesday.